Hello and welcome back to Math Class in Session. The inverse of a quadratic function. Example, given a quadratic, determine the equation of the inverse. Solution, you have to make a swap. X becomes y, y becomes x. That's what you have to remember. Next, in this case, we could multiply through by 2 to clear away the fractions. If we see a denominator, and we're trying to solve, well, we can always multiply through by the denominator. In other words, every single term gets multiplied by 2 in this case. So it will be 2x. It will be y squared plus 6. Isolate the y squared, turn it around, and take plus or minus the square root. Notice the range of the original is the domain of the inverse. Well, here's the original, and it's a parabola that opens up, that's been shifted up 3. So the range of the original is y is greater than or equal to 3. But if we look at the domain of the inverse, we can see here that 2x minus 6 must be greater than 0, which translates into x must be greater than or equal to 3. Because the radicand must be positive. This is the kind of thing you might notice. The range of the original is the same as the domain of the inverse function. The graphs of both original and inverse. Here we see y greater than 3 on the original. Here we see x greater than 3 on the inverse. I graphed them both using graphing software. And we can see that they are reflections about the line y equals x. Here's an example that involves graphing a parabola. It's not so much about inverses, but this one is about graphing parabolas, and that certainly is important to our study of quadratic functions in grade 11. Solution, well, let's put it into vertex form. There's the original. Factor out the 1/3. Checking our work, a third x squared is x squared over 3, good. And a third times 12 is in fact 4x. That also is good. And the plus 2 remains outside these brackets. So we factored out the coefficient on x squared right here. Now we have to complete the square. Take 12, cut it in half, square that, add it and subtract it. So it'll be plus and minus 36. Next, 1/3 will multiply by minus 36 and become the number minus 12. Repackaging the square. These 3 terms are repackaged into a square of a binomial, checking our work. Squaring a binomial, it's x squared, double the product, 6x doubled is 12x, and then plus 36, and these are combined to form minus 10. And so we have our vertex, minus 6, minus 10. And our task is to carefully graph this parabola. So here's our grid, and this is the original parabola that we were to graph, but we've turned it into vertex form, so now it looks like this. A very typical question. Graph this, turn it into vertex form so that it looks like this. And we know the vertex is minus 6, minus 10. So go there on the grid and put a point. Minus 6, minus 10, very carefully. And now the procedure for graphing a parabola. Go to the vertex, displace 1 to the right, and then go up. If the parabola opens up, go up the square of what you displaced. So if I go over 1, I'll go up 1 squared, but wait, 1 squared times a third, which is 1/3. And then because of the axis of symmetry that goes through the vertex, there must be a point over right there as well. Back to the vertex, now displace over 2. We'll have to go up 2 squared, which is 4, but wait, 4 times a third is 4/3. which is 1 1/3. So when we go over 2, we'll go up 1 1/3 and put a point right there. And because of the axis of symmetry, a point must appear there. Back to the vertex. Over 3, up 3 squared. But wait, 3 squared times 1/3 is 9 times 1/3, so that's 3, 9/3. Up 1, 2, 3, and put a point there. And because of symmetry, a point also goes there. Back to the vertex, over 4. Up 4 squared. But wait, 4 squared is 16/3. That's 5 1/3. 16/3, it's kind of like 15/3 with another third. So 15/3 is 5 1/3. So 1, 2, 3, 4, 5 and a bit. And a point goes there. And by symmetry, a point must go here as well. Back to the vertex, over 5. 1, 2, 3, 4, 5. Up 5 squared times 1/3. So that's 25/3. Well, 24/3 is 8. So 8 1/3. 1, 2, 3, 4, 5, 6, 7, 8 1/3. So a point goes there. And by symmetry, one goes here. Back to the vertex, over 6. 1, 2, 3, 4, 5, 6. And now up 6 squared, which is 36/3. 36 over 3 is 12, so we'll count up 12. Well, there's 10, 11, 12, and a point goes there. And by symmetry, a point must go there. Let's notice the y-intercept of the parabola turned out to be 2 when we carefully graphed. And if you look at this equation of standard form of this parabola, yes, the y-intercept is supposed to be the number +2. So everything is in order and consistent. Join the points together, and that's graphing a parabola, a necessary skill. Moving on, graph the function along with its inverse. Okay, solution, put it into vertex form, the best way to graph a parabola. There it is. Factor out the -2. Check your work. Minus 2x squared, good. Plus 4x, good. Take this coefficient, cut it in half, square it, add it, and subtract it. Then this last term will step outside the brackets and become +2. Meanwhile, we can repackage these three as x minus 1 squared. Checking our work, first term squared, double the product, last term squared, looks good. And we have our vertex at 1, 2. Now finding the equation of the inverse, that's not hard. First we have to do a swap. X will become y, y will become x. X becomes y, y becomes x. Then start moving things. So this +2 will pull across this equal sign, and the -2 will also divide under. We could turn this around because many people prefer to have y on the left. So we can just simply turn the equation around. Now take square root both sides. Don't forget to go plus or minus, and don't forget to include the entire fraction underneath a radical sign. Add 1 to both sides, and we have the equation of the inverse. So we have the equation of the inverse, and we have the equation in vertex form of the original, and the challenge was to graph the function along with its inverse. Let's do that. Here's the original question in vertex form, and let's graph it. We know the vertex is at 1, 2. So go to 1, 2, and put a point there. Now this particular parabola opens down because of the minus sign. So displace 1 to the right and then go down 1 squared. But wait a minute, better go 1 squared times 2. So 1 squared is 1 times 2 is 2. So put a point there. And then by the axis of symmetry, there must be one there as well. Back to the vertex, let's displace 2 over. Now we have to go down because it opens down. 2 squared, which is 4, but wait, 4 times 2 is 8. So we have to count down 8. 1, 2, 3, 4, 5, 6, 7, 8, and put a point right there. And by the axis of symmetry, a point must go there as well. And we've graphed our parabola because no more points are going to fit on that grid. There it is. Just join the points together into a smooth curve. And now the inverse. There's the equation of the inverse. But to graph something as complex as this, why not just invert all these points? Okay, so this is 1, 2, so let's go to 2, 1 and put a point there. 2, 1. This is the point 2, 0, so suppose we went to 0, 2 and put a point there. This is the point 0, 0. Well, when you turn that around, you still have 0, 0, so we can put a point there. Here's the point 3 minus 6. Turn it around, minus 6, 3, and put a point there. And finally, this is the point minus 1 minus 6. Turn it around, minus 6 minus 1, and put a point there. Join them together into a smooth curve, and you've graphed the inverse of the parabola. Notice how the inverse of a parabola that opens down is a parabola that opens to the left.